Trusses and halls, Lesson 1, traditional timber trusses. Pitched roofs are traditionally, even today, mostly wooden truss structures, which can be built in a wide variety of shapes and at different pitches. Both the form and pitch of a roof serve functional and aesthetic purposes. The primary goal of roofs is obviously to meet basic performance requirements dictated by climate, to protect the building from weather conditions such as precipitation, wind, cold and heat, while separating the interior spaces for storage, living and other functions similar to walls. The roof truss serves as the load-bearing structural part of the pitched roof, bearing the weight of the roof and transferring it to the structures below. The most commonly used roof shapes are as follows: gable roof, gazebo roof or pyramid roof, including special forms such as the dome roof and the cone roof, shed roof, hip roof, half-hipped roof, mansard roof, Dutch gable roof. We distinguish between low and high-pitched roofs based on the angle of inclination. This film shows you the most common traditional and contemporary wooden roof truss structures. Coupled roof. The coupled roof is a simple solution that can be used for spans of 5 to 7 meters. Traditionally, the rafter pairs are connected by a tie beam that rests on the wall joists with a single notched joint. Tie beams also form the structural system of the floor, creating a roof truss that is integrated with the floor. Sprocketed eaves are often installed at the ends of the rafters. The sprocketed eaves and rafter ends are typically joined to the tie beams using sailed mortised housing joints, while the rafters meet at the top with open mortise and tenon joints. The entire structure is reinforced latitudinally with wind braces spanning 3 to 4 rafters. In contemporary construction, coupled roofs are assembled directly on the completed floor structure. Rafters, typically spaced at 90 to 100 centimeters intervals, are attached to the wall plate by bird's mouth joints. The wall plate itself is anchored to the floor structure below using anchor studs. The rafters meet at the top with a butt joint resting on the ridge beam by bird's mouth joints. Pairs of rafter ties connect the upper rafter ends with single notched joints, providing full support for the ridge beam. Collar beam roof. The collar beam roof can be used for spans of up to approximately 10 meters. In this case, a horizontal compressed rod, known as the collar beam, is installed between the rafter pairs, acting as an intermediate support to prevent the rafters from sagging. The recommended maximum length of this is 4 meters. Traditionally, the typical design used was a sailed mortised housing joint or a dovetail lap joint. The major disadvantage of these solutions is that they weaken the rafters precisely at the point of greatest bending stress. In other respects, the roof truss is identical to the closed couple roof. Contemporary construction secures collar beams and rafters with cleats and straps which are fixed in place with stud bolts. All other joinery details remain consistent with standard closed couple roof construction. Purlin roof trusses. In many types of roof trusses, the rafters are also supported at intermediate points. The most common support method is purlins, which transfer the load onto posts or struts located in the principal trusses. Roof structures built this way are collectively referred to as Purlin roof trusses. The most typical Purlin roof truss is the double Purlin roof, spanning 10 to 12 metres. In traditional designs, the purlins are supported by posts positioned on the tie beams, which are laterally supported by inclined struts. Alongside the posts, the rafter ties also help to stabilise the position of the purlins. Knee braces reinforce the connection between the posts and the purlins. Typical joint types are as follows. Rafter ties and collar ties are connected to the rafters using dovetail lap joints, reinforced by stud bolts. The rafter ties connect to the posts and the purlin using simple notched joints. Similarly, the ridge beam and the collar ties are joined by simple notches. The struts connect to both the posts and the tie beams with sailed mortised housing joints. The posts connect to the tie beams and the purlins with straight tenons. Knee braces join the posts and the purlin through mortised housing tenons. Finally, the rafters are supported by the purlins with simple bird's mouth joints. In modern roof truss construction, both the posts and the inclined braces bear directly on a post plate. Joinery methods have been simplified compared to traditional methods. For instance, the rafter tie ends use simpler joints rather than dovetail laps. The triple purlin roof is an improved version of the double purlin roof. Here, the ridge beam is also supported by a post. It is laterally braced by inclined struts that follow the alignment of the lower struts and is fastened to the rafter ties with stud bolts. Knee braces connect the ridge beam and the third central post. This version is suitable for spans ranging from 11 to 13 metres. An interesting variation of the double and triple purlin roofs is the traditional mansard truss, which maximises usable attic space. The mansard design features a characteristic hipped broken roof profile, where the section below the purlin rises at a steeper pitch, while the section above it has a shallower pitch. Suspension trusses. Suspension trusses use tensioned beams and suspension posts to support horizontally positioned tie beams. In the past, this solution was used when it was not possible to provide column support. King post trusses span up to 8 metres. Suspension posts are installed at the principal trusses between the tie beams and the ridge beams. At the top, the post is hung by a stud bolt between the collar tie pairs, connecting the rafters with a dovetail lap joint. At the bottom, tie beams meet joist hangers bolted on the suspension posts. The suspension system is completed by inclined struts, acting as a compressed beam, which connect to the suspension posts using double-notched housing joints, reinforced by steel straps. The inclined struts transfer loads onto the tie beams near the supports, where they are connected with double-notched housing joints. In addition to the top plate and the ridge beam, the entire structure is also reinforced longitudinally with a principal joist connected to the tie beams in the principal truss with single notches. Queen post trusses. Queen post trusses hang suspension posts from the purlins. Purlins are placed on top of the rafter ties, suspending the tie beam at 2 points. The suspension system is completed with straining beams, horizontally compressed beams, connecting the upper junctions of the inclined struts. The straining beams and the suspension posts are connected with shouldered tenon joints, while the inclined struts connect to the tie beams and suspension posts using double-notched housing joints. When doubling posts, the principal joists are doubled also, and purlin connections are stiffened with knee braces at the principal trusses.